me though. Say you had trouble with 15, 16, and 17. Lord, if all of y'all had trouble with that. Oh, okay, 15. The integral 36x squared tangent 4x cubed minus 5 dx. I'm going with u as 4x cubed minus 5. 4x cubed minus 5. Du is 12x dx. Oh, okay, sorry. All right. Yes. I got excited to tell y'all about the other. All right, so I need this to be 12 inside. Y'all know what I like to do. I like to just take this out to start with so that I can just visually see what I need. I need a 12 in here, which means I need to divide by 12 out. Does that make sense? Yes. Yes. So I end up with 3 times the integral of tangent u du. What is the antiderivative of tangent q? Oh, crap. I think I know what we have to do, but I don't want to do it. What are you, which one are you talking about? And that's secant. But wait. Remember, but I can't divide integrals. Oh, this one's hard. Did anybody get this one? You did? Oh. Okay, let me try to work backwards. Where's the log? Did you get it, Jalen? Why did you think there's a natural? Mm-hmm. I'm not gonna lie. I think that this is I don't see how to do this without integration by parts. I can't. We're not doing integration by parts. 16, 17 were the same way. Uh, Come back to this one. I don't think we're gonna be able to do that one without showing you. Integration by parts, and we're not. Let's go 15 for now. I'll go back and Let me think about that one. Let me think about 15. Yeah, skip it for now. You're not going to see anything like that. Okay. 16 is 2. What was 16? It says, no, 16 says inverse tan of 4x to the 5th over 3. If you took, I think we can do this one. I think we can do this one because if I try to get this to the pattern of 1 over 1 plus x squared, so I factor 9 out of the bottom, right? The square root of this would be 4/3 x to the 5th. So if I let that be u, so du would be 20 over 3 x to the 4th, right? I've got 20x to the 4th, I just don't have the 1/3. This might not, let me see if this works. 3, here's my du. So I've got 1 over, oh, I didn't put the 9 out there too. Right? These are hard, y'all. These are really hard. You might have one multiple choice that causes you to do some type of manipulation, but I don't even think this difficult of manipulation. But this is like what we were doing yesterday. So it'd be 1/3 inverse tan of u, which is 4/3 the 5th. Yes. This one was kind of hard. Look at 17 because it's the same kind of thing. So I recognize it being with that square root on the bottom. I see these same values keep repeating themselves in here. So I know that there is some derivative that is 1 over the square root of, there's a minus there, 1 minus x squared, right? Which one is that? Inverse sine, right? So if I can get it to look like this, then I can use inverse sine for the integral. So I would need that first one again to be 1. So I'm going to come over here and play with this little 25 minus 25x to the 10th real quick. If I take a 25 out, I'm left with 1 minus x to the 10th. But what's the square root of 25? 5. So this is really 5 times the square root of 1 minus x to the 10th. Does that part make sense so far? A little bit. Okay, so this is, I could rewrite this, and I haven't done any type of integration or anything like that, but I could rewrite this as 25x to the 4th over 5 times the square root of 1 minus x to the 10th. 25 over 5. I'm going to pull that outside. 1 minus x to the 10th dx. Now, if I let my u be, now remember the pattern. The pattern I'm trying to get it to look like is this. So what should u be? X to the 5th, not x to the 10th, because that would just be 1 minus u. I need it to be 1 minus u squared. So I'm going to let u be x to the 5th. Do you see that? So du would be 5x to the 4th. Which if I hadn't taken that stinking 5 out, I would have. There's du. So I have 1 over 1 minus u squared du. Read the room, Stacy. Read the room. Pretty terrible right now. Go ahead. What's your question? Figure out what? Yeah, the 5 we cancer. So this was my, all that together makes up du. So if I do u squared is x to the 5th. If I square that, it becomes x to the 10th. If you struggle with those last two, it is okay. Those are tough. Y'all okay? Other than the last two, are y'all okay? Yes. Thank you, Drew. I appreciate that. Thank you. Good. Yeah. Yeah. Well, I'm glad y'all thought that because then we're going to add something to it. Just a little something. Just a little something, something. Ah. My nose stopped up again. I'll give y'all a minute to turn your homework and stuff. We probably don't have to spend a whole day on this, but it's okay. We're actually like a day ahead right now, so that's a good thing. So we'll kind of take our time easing in. It won't do anything but concrete. We'll probably need that extra day when we get to volumes of revolution, though. All good. All right, so what happens if February the 1st? And there's only 4 weeks. What happened? Still no snow day. But we do have a 4-day weekend. We do. That's awesome. That's amazing. The week of February, the week of Valentine's Day, that Friday we're off, and then the following Monday we're off. I don't know. President's Day and something. So Valentine's Day is on like what, a Wednesday or a Tuesday or something. That Friday we're off, and the following Monday we're off. That would have been smart. Like in spending money. No, not first. She said some people every day get like a drink and a shake.
Some people go get a tea in the morning and then go get like a shake at lunch. Like they'll split it up. But that would cost them more.
Yeah.
You get a combo, you get
You are. You just don't know, but Henry's the one that beat you out of that number one spot. He's actually. You didn't like it?
No, Grayson gives this like.
The drink I got when I was
And it's so good. I like the key lime pie one too.
when I actually went to
That was good?
Well, I mean, there's no like secret.
That's why you haven't been back. What's the antiderivative here? Ooh, yeah. You got this, Claire. You got this. Okay.
I would say like.
I'm gonna do a usub here. I'm gonna do a usub because look, if I let u be, what would you let u be? Look at y'all, x squared minus 4. So what's du? 2x dx. So bless you, I need a 2 in here, which means I need a 1/2 out here. Now here's the problem. It's not indefinite anymore. So here I've got 1/2, 1, 0, and this is where I'm going to show you 2 different ways that we could do this. Because I've got u's here now, I have to take that into account for my bounds. Okay, so if I want to say, what's the antiderivative of 1 over u? Natural log. Natural log of u. I can't go from 0 to 1 anymore because I don't have x's. Those were in terms of x's. So I could rewrite my bounds in terms of u. What is u? Well, u is x squared minus 4. So I could say this one would be 1 squared minus 4, which is negative 3. Negative 3, and then 0 squared minus 4, which is, what the heck? Negative 4. Because in here I don't have an x anymore. Okay, this is option 1. This is, yes, I'm writing them in terms of, so method 1, change the bounds using your u formula that you came up with. Same formula, but here. Yeah. So you got to counter it outside. Yeah. Because you got to keep the same value, right? So essentially what I'm doing is I'm doing this and a half, and 2 cancel each other out. But I'm leaving what I need inside, and then what I didn't need, I'm throwing it out there. Yes. Yes. So now I don't have to go back. I can just leave this as 1/2 and then evaluate natural log of negative 3 minus natural log of negative 4. That's method 1. Method 2, and really I don't have a preference either way. You just have to remember that something has to be adjusted. Method 2, you leave the bounds alone and substitute your u in your equation. So what I mean by that is, here I would have 1/2 times. I'm not going to do log of u. I'm going to go back. What was u? U was x squared minus 4 from 0 to 1. Well, now I need to evaluate. So 1/2. You're ending up going back and doing the same thing at the end of the day. It's just when do you want to do it? Prior to or after? I find it easier to do it in the beginning. I like method 1 myself, but whichever you prefer. This would be natural log of negative 4 whenever I put the 0 in. Oh, just kidding. I have to do 1 first. 1 squared minus 4 minus natural log of 0 squared minus 4, which is, of course, the same thing. Negative 3 minus. I feel like I need to show you just because, and I didn't show it to you initially because I didn't want you to get caught up in this, but I need to show you this in case this shows up on multiple choice. You do need to be able to work with your logs in condensing. By the way, do I have this on your sheet? Okay. Where's one over at? Yeah, I don't. I can't do the log of a negative, right? Think about what it means. E to the what power would give you a negative number. There's nothing you can do. So you always do the absolute value here. So this is really going to be positive 3 and positive 4, but here's what you have to be able to do. Here's where it gets confusing, y'all. Hang on. You can't take the log of a negative number, because remember what log means. If I'm natural log of, say, negative 3, that's saying e to the what power would give you negative 3. Well, there's nothing you can raise e to get a negative number. It's never going to be negative. So we keep it, it's the absolute value here. That's why you see some absolute values in the some of the answers. Okay, but as I simplify this, y'all remember those log properties, condensing log properties? If I divide, what does that mean I do, or I can do? Oh, gosh, dog it, I said, if you subtract, that means you divide. I said it backwards, I'm sorry. I can condense it down to just one log expression like this. And then I can take it even a step further, if I so choose, and say, do y'all remember these? That's the exponent one. Now, you're perfectly okay to leave it any of these ways, but if you're in a multiple choice situation where they've got, this is one of the answers, or maybe they even have this, you have to be able to recognize those. Y'all need me to recap the log properties real quick for you? Are y'all okay? I'll do it. If you're adding, you can combine them with multiplication. If you are subtracting, this is all if they have the same base. You can divide. And if you have a number out front that you're multiplying, you can bring that around as an exponent. 3 whole properties backwards and forwards. Yep. As y'all copy that. When do you need a C and when do you not need a C when integrating? Indefinite needs a C. That's exactly right. Indefinite needs a C. Definite does not. Good job. One more. If you can get this one, I'll stop. Oh. Indefinite. So if there are no bounds, you need a C. If there are bounds, you don't need a C. That's a pi. Evaluate the integral. This one's pretty straightforward. Y'all get the U and the DU? So at this point, I have to decide, am I going to adjust my bounds now? Or should I evaluate and then adjust the bounds? What do y'all prefer? What do you think? Now? I agree. I think now is the easiest because the antiderivative of U is very easy. So I'm going to say my first bound, this is going to become the tangent of pi over 3. This is going to become the tangent of 0. Right? Both of those coming from that U equation I have set up right here. Well, what's the tangent of pi over 3? Square root of 3. And what's the tangent of 0? 0. What's the antiderivative of U? Evaluated from 0 to square root of 3. So now I have 1/2 square root of 3 squared minus 1/2 0 squared, which is 3/2. What you think? Yes, no, baby, so we don't care.